Hey, Jonathan here at Colfax Math. In this handout right here, I have a series of problems. They're kind of paragraphs, written scenarios, and you're supposed to identify the kind of function and then sketch a graph of the relationship between the two variables. This is a kind of common problem on a standardized test, but also a common problem in an Algebra 2, Integrated 3, Trigonometry pre-calc class. So this is actually for an IB Math SL class, but given a scenario, identify the function and sketch it out, and I'll talk about the 5 primary kinds of functions we look at and how you could identify them. So let me put the camera over my shoulder and we'll get started. So before we get started here, let me do a quick review. Y is always your vertical axis. It is your dependent variable. And X is always your horizontal axis, and it is your independent variable. The way you regulate possible values of X is what's called a domain. So those are, say, X is greater than or equal to 0. The way you regulate values of Y is with range. So if you only want to work in the first quadrant, you would say X is greater than or equal to 0, and Y is greater than or equal to 0. Okay, the 5 primary functions we look at in here, number 1 would be a linear function. A linear function would have a general equation, something like y equals mx plus b. It would be a straight line linear. Number 2 would be nth power function, where the exponent is a number, not an unknown. So something like y equals kx to the n, and an example of that would be a parabola, y equals 5x squared. So that's nth power. Our third function would be exponential, and the big difference between an exponential function and an nth power is the exponent here is a variable. So the general equation is y equals ab to the x. So x is my unknown, my independent variable. So an example would be something like y equals 2 times 3 to the x. So you take your independent variables x and plug them in for x to solve for y. Fourth would be a quadratic function. General equation y equals ax squared plus bx plus c. And an example of that would be something like y equals 2x squared plus 5x plus 10. Quadratic formula would work on that. And then fifth is a function that repeats itself, and that's called periodic. So a periodic function would be something like y equals sine of x. The general equation is pretty long for a trig function. The general equation is y equals c plus a sine or cosine, b x minus d, but we're going to work on that much later. An example would be something like y equals sine of x, where the graph would start at 0, say, go back to 0, back to 0, back to 0, back to 0. So a graph that repeats itself would be periodic. So those are the 5 functions we can draw from. Now that we have those, let's go ahead and get started on this. So for each of the following, sketch a reasonable graph and identify the type of function. So the depth of water at the beach depends on the time of day. So depth of water and time of day, those are our 2 variables. Does time depend on the depth of water or the other way around? So depth of water depends on the time of day. And something like that would be, you would have a high tide maybe at midnight, a low tide at noon, back to a high tide, back to a low tide, high tide, and you can see it's repeating itself, and that would be a periodic function. Okay, number 2, the distance required to stop your car depends on how fast you are going. So on this one we have distance to stop, so we have distance to stop, and how fast you're going, speed. So distance to stop for speed. Speed would be your independent variable, and distance to stop would be your dependent variable, right? How long it takes you to stop depends on how fast you're going. Well, we do have one value, like 0. When I go 0 miles per hour, it takes me 0 feet to stop. As I start to go faster, it takes me more time to stop. And then actually at like 70 miles an hour, it really starts to take a ton of time to stop. So it is increasing at an increasing rate. It does go through the origin. So number 2 would be nth power. Something like half a parabola in the first quadrant. So you could regulate it with the distance being positive and speed being positive by creating a domain and range. X greater than or equal to 0, y greater than or equal to 0. Does it look like that? It might not be exactly like that, but it's certainly not linear. It certainly increases at an increasing rate depending on how fast you go. And that's why traveling so fast is so dangerous. Okay, number 3, the temperature of a cup of coffee, depending on time, really, since it's been poured. So the temp is going to depend on time. So that cup of coffee gets poured at a certain temperature, I don't know, at time 0, probably comes out of the coffee pot at maybe 150 degrees. So I start at 150 and it starts to cool off. But it's actually not going to cool off to 0 degrees. It's going to cool off to room temperature. So let's say room temperature is 70. And it's going to actually decrease like that at a decreasing rate until it becomes flat. It's never going to get colder than 70. It's never going to be hotter than 150. The range would be between 70 and 150. So it would look like that. It's an inverse function because it's x is going up, y is going down, and it's exponential. So this function is exponential. And it's really a rate of change that you're looking at. And you could tell the differential between room temperature of 70 and 150, where it comes out of the coffee pot, is so high it's going to cool off quickly at first, but once it gets to 71 degrees, it's going to cool off a little bit slower or a little bit less. Okay, let's take a look at maybe just 1 or 2 more, and then I'll let you do the rest. As you breathe, the volume of air in your lungs depends on time. Well, they tell you which axes those go on. Time is almost always your independent variable. And air in your lungs, I don't think you ever get all the air out of your lungs. So let's say you breathe in, get a big breath of air, and then you breathe out, breathe in, breathe out, in, out. So you recognize that as a periodic function. So that's number 4. I won't go over all of them. I'll let you figure these other ones out. I will say number 10 here. This is a really hard one that I'm sure you'll be able to figure out. But it's going to take a lot of thinking, and you have to think about the slope of a line. So I won't do number 10, but I'll just get it started for you. A straight line starts along the positive x-axis. So here I am. Here's the straight line along the positive x-axis. It rotates counterclockwise, like that, around and around the origin of a coordinate system. The slope of the line, so now I need to graph this, the slope of the line depends on the number of degrees. So slope depends on degrees of rotation. So I guess I have to identify what slope is. So I could be here. Slope is rise over the run. So slope is equal to rise over the run. So you have to figure out what happens at 5 degrees. What's the slope of that line? At 10 degrees, at 45 degrees. Well, actually, I'll put that one in there. At 45 degrees, the slope of that line, the rise and the run are equal. So at 45 degrees, my slope is 1 over 1. So I do have 1 point. And then what's happening to that slope as that angle gets larger and larger until a point, and then I'm going to rotate past 90 degrees, what's happening to that slope from there around. That's just a starter. I'll let you figure that and the other problems out. Hopefully that'll get you started on figuring out the type of functions given a scenario or a sentence, identify it and sketch the graph. Really good skill. Any sort of analysis is usually trying to identify what kind of function it's going to be. Okay, well, thank you for watching. Love to hear your comments below.